Hi, my name is Krynauw. I work for a company called Alice. And in the next half an hour, I would like to take you through some of the stuff we've learned around building models, and particularly the finance domain. Hopefully, there's one or two things you can take away and try it at your own organizations. I was hoping to do this live, but let's see how this sort of recording goes. Okay. Cool. So just who's Alice? Alice stands for Autonomous Learning Investment Systems, and we really just a sort of a division or an independent quant team within the Resco Asset Management Group. We've always worked together, and there's quite a close symbiotic relationship between the Resco investment team and the Alice side of the business. Alice, just a slide on the team, it's a bunch of engineers and finance. So it's really sort of, the idea is to combine the sort of deep investment experience with technical expertise, and how can you really sort of join them together in a sort of most elegant way. So firstly, what is investing? Investing we define as a synthesis of information with the purpose of really pricing it as an asset. In other words, we need to make a prediction based on a whole lot of sort of information out there. And how do we condense or synthesize that to a single sort of prediction? Now, there's often two stories in the machine learning domain. The one is around signals. Signals is not what we're talking about here, but examples would be, things like using machine learning to scan or count cars in parking lots. You do it for a couple of retailers and get a sense of their revenue streams or predicted revenue streams based on the parking activity. We're not talking about those. Those are using machine learning techniques. What we're going to focus on is more how do we use machine learning to synthesize all these information into sort of one place. In finance, it's the data is always often like all over the show. Markets just continues changing, so data is not stationary by design. But one particular thing that really sparked this sort of machine learning concept within the team was this idea around how interactions between stocks are non-linear. And there's a lot of dimensions. There's often trade-offs between two different stocks, two different markets, etc., etc. And I'm going to sort of run you through a pretty straightforward example just to illustrate the point. So a typical manager has got a universe that it looks at. It needs to pick a stock. Now, one option that you could go do this is really fill out a couple of columns full of features and characteristics of stocks. Now, you might look at price earnings ratio. What does this thing is it pretty expensive or not? Free cash flow yields. You then expand it and you look at more things. You look at growth rates of stocks. And you start coloring things in, and you build on and you sort of look for more and more features to get this list of stocks, which could be thousands of stocks, to a manageable list where you can do some more sort of work with. Now, conceptually, when you look at it, is really you're slicing and dicing this thing in linear fashion. So you take a universe, you say, cool, I'm interested in oil and gas. You slice that, and you slice that, and you look at their sort of fundamental features and characteristics, and you end up slicing until you have a manageable universe that you can go and give to your analyst that basically can do the actual sort of stock by stock investigation or sort of analysis. So all it is like essentially just a slice of a whole lot of linear equations or slicing and dicing. Now the interactions between these, like what you see here, they're not linear. They're not in one dimensional. It's not like a 2D screen. So there's a lot of those characteristics which you apply through these, it's called screening methods that's still sits in the sort of a linear space. When you look at some of the newer sort of neural nets, things like TensorFlow, which is a software open source by Google, that you can go and download and start building these models. And what it allows you to do is actually model the non-linear components between stocks and between between variables and ideas. And if you break it down, you can almost think of it as you take not 10 linear equations, you take 1 billion of them, you solve it, and you come to a prediction. So it was sort of a sweet spot. Is we got to look at this thing. This is about 5 years ago. We got to look at this thing in more detail, because it seemed like quite a nice fit. Now, when you look at over the last couple of years, you know, in the 80s, you know, I was barely born there, and you had like statements, you know, paper-based. In the 90s, you had sort of the spreadsheets sort of came out, SuperCalc, you know, Excel, and all those things. Then moving onwards, in the you know, there was this whole big data sort of movement where, you know, a lot of these tools, the BI tools, things like, you know, the brilliant stuff out there, Tableau, ClickView, Looker. There's a whole ton of sort of big data, which allows you to sort of visualize just big data. And you had to look at those things. Now, move on 10 years, we're in the 2020s now. AI has to be some portion of that, or at least you've got to look at these things in your business. So it feels like quite a natural progression. You know, in the 90s, if you didn't have a spreadsheet and you were sort of in the accounting game, you couldn't. There was no way you can compete. You sort of with guys who had spreadsheets, and I think we're sort of in that same scenario where you have to look at AI. You have to look at some form, applying that in some form or another in your organization. So we had a bit of a journey in 2015. TensorFlow was launched. It's open source, it's free, you download it, and you start building models. And you're like, cool, it feels good, and it's like a excitement. And the reality is there's a lot of sort of things that you need to be very careful about, because these models are super complex. They can fit. They can find if you've got errors in your data, if you've got any sort of look-ahead bias, or they can pick it up. So you've got to be quite careful, and you read a lot of white papers, etc. And often those things say at the bottom is, you know, these are ideas to enhance your models and make it better, but you got to try it out yourself. You've got to essentially just apply it on your own data and sort of make a decision. So the problem we sort of ended up having is, yes, you can build these models, but you've got to like start actually like iterating faster and faster, and that's when scale became a big thing for us. You can't have too long iteration cycles between models, because you've got to sort of keep the momentum going. So scale became like a really, really key thing that we had to solve. And when you look at the tech side, in a way, everything reduces to scale. In other words, when you think of sort of things like Kubernetes out there, sort of technologies out there, a lot of it is built around scale. You know, spinning up one machine is pretty straightforward. Spinning up 4,000 of them and managing them and like handling sort of errors is complex. So in the next few slides, I'm going to go through some of the stuff we've learned along the way around how do we deal better with the concept of scale. So the first thing was Jupyter notebooks. Now they are great tools. My first sort of Python script was probably in a Jupyter notebook. It feels good. It's quite a nice environment to sort of play with. But production-wise, it's a mess. You can't have Jupyter notebooks as a sort of development environment. It's just, you can't, especially sort of in the finance game, there's like you've got to explore, and if you find something, you've got to be able to productionize that quite sort of elegantly and quickly. And there's no way you can sort of have this model, build it in a Jupyter notebook, and then want to productionize it and then move it over to a production environment. It's just, you don't have the time for that. So you need a proper IDE, yeah. So long-running tasks. I mean, there's a whole ton of things around Jupyter notebooks, and there's lots of sort of details out there. But you need some form of integrated IDE. So there's things like PyCharm, VS Studio. There's a VS Code. There's a couple of sort of free open ones out there that just sort of get used to those things. I would definitely sort of stay clear from any sort of Jupyter environment. And a lot of those things help you with sort of things like Dockerization, implementing your CI/CDs, proper version control. It's just a no-brainer once you get into the more sort of production environment. The other thing that sort of, it's probably a bit of a sensitive one, but it's, you've probably heard of Pandas. Pandas is probably, for me, this is a Panda. They're great. I mean, like there's like NumPy, and it forms the basis of a lot of tools out there. But just be careful to build like exceptional like layers and layers of logic in your Pandas data frames. Pandas is a sort of obviously a library within Python that helps with sort of matrix multiplications and things, and not really, data frames as per se. And it could quite quickly become quite hard to actually get a feel for what's actually happening with this particular table. So just be careful of sort of nested pandas, and often we found just in our sort of space, things like we're using BigQuery as an example, using just like sort of structured SQL components. In other words, you have a very defined order of events and sort of process and transformations that gives you visibility at each level. So in my view, sort of a decent, elegant SQL script can probably get you further, give you more mileage than a sort of a nested Pandas setup. Cool. Enough about Pandas. Just then on team. So team, how you set things up is obviously quite important. So we've went through a couple of iterations. So in our world, we've got the sort of machine learning side, and this is where everything started. That's where we build models, and we call it domains. So we set up the machine learning domain. Now, machine learning needs features. You can't just throw data at it. You need to have some domain knowledge applied to these features on that. So we call it feature engineering in our like a FE domain, and it's a team that deals with generating features. Then the features need data, so you have your data engineering, those where you onboard your pipelines, your finance. The one big challenge is the data is just all over the show, and there's often new data's in poor formats, there's integration with old tech, but there's no sort of scope for trying things out manually, and then once it works, you want to productionize it. So you almost have to have some sort of production-first mindset in the data engineering side. So we've set this up. Then, in terms of the finance guys, they don't understand machine learning, so we convert those predictions into portfolios, and we construct them using sort of optimization techniques, etc. But it's really bringing those predictions and those sort of loss functions and stuff into the finance domain. They understand what the Sortino and risk, standard deviation, attribution, contribution is. They don't understand loss functions. So we've got to bring that in together, and then to really be properly evaluated, you've got to trade those signals. And from the trading, you get like a real objective way of proper in-sample or out-of-sample validation around, how good is this thing, and really closing that loop and cycling back. Now we've set up the whole team to interact with each other only through APIs. So all the connection points between the different teams, if ML wants to talk to FE, hit an API. You can't sort of dig into their stack and get what you need. You've got to have clear API layers across, and it sounds simple, but these teams are not silos. They're not in sort of, we have a stand-up, the whole team is in the same meeting, in the daily stand-up. So the team members know and have a feel for what's going on in the different domains, but they're responsible for their domain. In other words, if a data engineering pipeline falls over, it's not machine learning guys to go and fix it. It's completely data engineering. So the responsibilities are very sort of clear when you look at these sort of these domains, but the sharing is sort of across everything. Cool. So that's just, and that really, like those ownership at domain level just unlocked, just for us, a lot of efficiencies. What also happens then, because you've got these structures, you can then onboard external developers quite easily. You say, cool, I need some help with the training integration. You get someone, you put them in the TD domain, and that's all they do. They don't have any visibility around the rest, and they can start developing. So, and this allowed us to sort of, over the last 2 years, been able to really like tap into developers across the globe, without really worrying about things like NDAs and like opening up the entire stack for everybody, because you can really sort of outsource it. The second part of integration was really around the finance guys. So let's say, you know, the risk asset management is a local long-only sort of asset manager, and they have a team of analysts. And the idea is we need domain knowledge in the team, you know, to build models. And how do you seamlessly integrate? And that's what you have to get right. So firstly, you've got to understand their framework. Like, how do they operate? And this particular team has what they call the investment process, which are 6 steps. What's happening where? So we sort of played with the idea of having Alice as a member of their team. So Alice makes a recommendation, you know, scans a set of stocks, rank them, and come up with a recommendation. And by almost like placing Alice in their team, for them it doesn't feel like it's a change in process. It feels like it's just another member in their team that they need to look at. So what happens is, at this step is oh, hang on, if you look at almost like this step, that's where Alice really like generates a lot of ideas and scan, and then the ideas are being fed through this sort of level 1, 2, and 3 stages, where it's really around people looking at those ideas and writing reports on them, etc. So the beauty is then, because Alice is in the team, those ideas are either recycled or promoted into the rest of the team, sort of into the portfolio. So one almost get like a real-time feedback of these ideas as they evolve through their team. Now, practically how we've done it, we use sort of Asana as a sort of, so Alice just became a member, and really like in their, what they call their idea factory, they generate these ideas and create sort of ratings on that. Now, Alice can then learn from those. So in this way, it doesn't feel to them as like this change in process, because they like what they're doing. They're happy with how they've been working. Cool. Then model research cycles. This is like such a real thing that we probably experienced about 2 years ago. Is you start building more models, and the whole thing around dimensionality. Now, I'm not going to run. I've got a few minutes on this, but I'm not going to run into all the details. There's a bit of jargon here, but the concept is it's just something simple can scale exponentially quite easily. So let's say you've got a problem with regression or classification. If you want to test which is the better one, you run 2 models. Then you say, okay, hang on, we also need to do a label choice. Now, label is what we're trying to predict. So in other words, we want to predict the next 10-week or 1-week move or rank on a particular stock. We might 1 week, maybe 3 week, etc. So we can pick a few of those. Now, which one is the best? You've got to try all of it. So in this case, you've got 20 models. Then you say, okay, cool, what architecture do we want to use? Do you want CNN, RNNs, deep neural nets, etc.? There's all these vanilla architectures. Then there's like, how do you tune these models? These are all terminology that you'll be familiar with if you've sort of built any models, but those are really knobs that you need to make a decision as a machine learning engineer. And you can see the number of models, just to test those things, are quite simple. Then you add a couple of more features and more. And at this point, it's all been non-finance related. They're all just standard sort of neural net architectures. Then we look at markets. So suddenly you have this sort of this blowout is, a particular model for the South African market is not going to graph or work for a European market because the dynamics are sometimes different. The data is different. So you've got to try those things out. You've got to try, you can't necessarily expect the same performance on one sector, i.e. the oil and gas versus financials. So you've got to try that out. So just like that, you get to this, how many models do I need to run to cover all these things? And then there's little time where over time you've got, the last 10 years quarterly models, so you've got 40. So suddenly you just blow things up just like that. And for that to work, you absolutely have to have some sort of framework of how you can monitor and track these things. There's Kubeflow, there's a couple of tools out there, there's Apache Airflow, there's things out there that can help you with orchestrating all these things, but you probably got to spend a decent amount of time just to figure out what's this process or framework you're going to work with. I won't go into detail, but we've on our side have got this event-based operating system. In other words, called Alice operating system. I can always offline talk about how we've done that, but it's really a concept around events. It's our whole lives are full of events. I get an email, I respond to that. That's an event which I respond to. I get a phone call, I pick up the phone. That's another event. It's a very simple event. The complexity sits in how you string all these things together. And many events, it becomes impossible to manage that unless you have a decent framework. So we've set up this event sort of setup which uses a lot of PubSub, serverless functions, key value storage, things like Firestore, Google Firestore, etc., to sort of manage this thing for us. Because without that, you can't keep track of all these things. Then there's another thing, just like one of the things we learned from, you can see this, there, that's not there. This sort of web side of things. Now, there's often learnings you can take away from by looking at what's been done on the web. Because scale has been a big part of that, and scaling a simple task makes it complex. I don't care, reading one email is super basic. Reading 400 million of them is complex. You need something else to handle that. So you're constantly looking for ideas, and one particular one is this concept of a website, where a lot of these tools, Kubernetes, Cloud Functions, all those things are geared towards scaling very simple things, but quite well. So you might have a website serving one user is super basic. It's here's your content. Serving 100 million is quite different. So in this particular example, we've said, okay, let's say we got to go and hit an API to get a particular bit of detail for that. So in other words, in this example, is you can sort of open Figgy is one of those providers out there. We give it a company and we get a ticker. So it's one hit. Now, if you practically measure what's happening there, you'll see, you'll have. This is obviously quite a theoretical exercise, but if you do that in series, you might have 65,000 companies, which is not unreasonable. You want to pull, 5,000 days, pull daily, in terms of maybe a bit of history. Suddenly, this thing just blows out. So one of the things we said, you can spin up one machine that does it in parallel, and it sort of works, but you often have this input-output issue with handling all those connections. So what we said, okay, how can we translate something that came from the web, i.e. the scaling independently, but many, into this thing. So let's take a simple example. Let's say we've got 6 tickers there. And the logic is, we put it on a cloud function, which basically just spins up and scales. AWS Lambda is a similar concept. One cloud function. And we say, cool, let's give it a logic. If my list has one ticker in it, go and get it. Otherwise, split it in 2. So it's very simple. For each function, that's all it does. It just applies that bit of logic there. Now, if you just do the math, it's like, let's say if we split it by 4, so you get one function, 2, 4, and they just quickly, within 9 steps, you end up with 65,000. Now, a lot of these tools are geared for that, so they can spin up and it just blows out. So applying that sort of same concept is, you have one cloud function that sits there, or AWS Lambda function, or i.e. some serverless thing that can scale, that just blows up in this sort of fashion. And suddenly something that takes, hours potentially could take a couple of minutes, depending on how aggressively you scale. The other thing is, like, data pipelines are hard because there's sort of these inconsistencies. Now, humans are quite good at handling inconsistencies, and here's a good example is, you might expect a sort of a particular file with commas separated, and then one day you get a semicolon, which is not the same. So what happens, you need to have a framework where at that point in time, you've got to alert the human. So what we do, we go in sort of Ubuntu state, but all it means is that in the human world, we get a task and say, hey Jan, there's an expected delimiter that wasn't found in that CSV file. Cool, the human then goes, take that file, change the delimiter and put it back, and off the machine goes again. So you've got to have like a quite an elegant way of triggering the human intervention. When do you need people involved, and not necessarily through error logging and like that sort of thing. So, and this example here is just a bit of read. I've got a few minutes left. We use Asana. Asana is there's Trilio. There's a couple of tools out there that does sort of project management. So Asana listens to what happens on the operating system, and anytime there's something that goes into what we call Ubuntu state. Ubuntu is a Zulu word for person, and it really just highlights to the operating system that, hey guys, I'm not sure what to do. It's not a failure, but I need some human intervention. So what happens is, we've got this concept of, again, like a task is an event. Asana would be listening to the operating system, say, oh, cool, there's an Ubuntu there. Take that particular state and convert it into a human readable task. I would then go and like change the state of it in my Asana naturally, because it's been allocated to me. That will then go back to the sort of the framework or the operating system and say, cool, the thing is running again. So you've got to like seamlessly integrate with as many sort of as many points as possible. And sort of the last thing is the sort of concept of everything is an endpoint. There's like a really cool stuff around things like GraphQL, where we essentially have like a GraphQL API endpoint across this entire stack that just brings all the domains, everything together under one end-to-end endpoint. Also within each domains, if you want to talk to a particular model or get any details on particular models or particular data sets, you've got to go through an endpoint layer. So it's obviously not a new thing. It's very much the sort of the Amazon way of everything becomes an endpoint organizationally, but it's really, if you do that well, it really takes out a lot of friction in the stack. Cool. I hope, it's obviously a bit rushed, but I hope there's a few things you can take away from this, and enjoy the conference. If there's anything specifically you want to sort of have more details on, there's our details. Give me a call, send me an email. I'm always happy to chat about these things. Cool. Thank you. Cheers.